Hello, Girl Scouts of Western Ohio. My name's Renee, and I'm talking to you from Imagination Station's Distorted Gravity Room. We know you can't visit us right now, so we're going to bring some small pieces to you. Here in the gravity room, the floor is at a 25-degree angle. However, unlike a hill that's at a 25-degree angle, it seems hard to keep your balance in here and things just look wrong. Here in the gravity room, the visual cues are designed to trick your mind. The doorway, the shelves, the countertops are all at a different angle than your mind expects. Now to Megan for some messy science.
Hello everybody, at Imagination Station here, we like to take things to the extreme. And we're going to be doing one of my favorite demos, and that's because we get to use chemistry to make a mess. What we have here is H2O2. It's very similar to water, but it does have one extra oxygen molecule. That's going to be key. So, you might not know what it is, but I'm sure you guys have it in a brown bottle in your medicine cabinets at home. This is hydrogen peroxide. Now, hydrogen peroxide is very special because when it interacts with light, like it's doing right now in my beaker, it actually starts to break down from hydrogen peroxide to water and oxygen gas. That's why we keep it in brown bottles, to prevent the light from getting inside the bottle and breaking it down. And so what we're going to do is we're going to actually capture that oxygen molecule that escaped when it breaks down. All right, but we're going to need some other ingredients with us. So here we have potassium iodide. That's going to be our catalyst to help us speed up the reaction. And in order to catch the gas, we need something to make bubbles. So we have Dawn dish soap here. All right, so first we're going to take our hydrogen peroxide and pour it into our graduated cylinder. All right. Another thing for you guys to know is that our hydrogen peroxide is much stronger than what you find at home in your cabinets. This is actually 35% concentrated, while this is only 3% concentrated, so it should give us a huge mess. Now, I'm sure that's kind of hard to see, so we're gonna add some coloring to it. This is just some simple food coloring. You know what? Let's just dump the whole bottle. There we go. I like bright colors. So now we'll give that a swish to make sure that's all mixed around. And we're gonna now add our Dawn dish soap. We have 100 milliliters, or 50 milliliters, not 100, of Dawn dish soap. And as you can see, we don't have many bubbles. So we're gonna see if we can incorporate some more bubbles. No, that's not the mess that I'm looking for. So in order for this to happen and for us to get as many bubbles as we would want, we'd have to sit or stand here for 6 to 8 months. I don't think we have enough time for that. So we're gonna speed up that process, like I said, by using our catalyst, potassium iodide. It doesn't interact with the actual reaction. It's gonna produce the same amount of bubbles, but it just helps speed up that process. So now it'll only take about 6 to 8 seconds once I pour this in. So, are you guys ready? Are you ready for bubbles? It's gonna be mountain bubbles. All right, so we're gonna uncap this and we're gonna do a big countdown. Are you guys ready? Say it with me. In 5, 4, 3, 2, 1. And we're gonna take a step back so I don't get covered. And look at the bubbles go. What do you see? Nice, there we go. Look at all of those bubbles. Now that is a mess. Now, I don't know if you guys can see, we actually have steam coming off the top of our bubbles. And that is because this is actually an exothermic reaction. It gives off heat. So it's very hot, so we don't want to touch the bubbles either. Now, that is what I call a mess. So now if you want to try some really cool science at home, we're going to head on over to Caitlin, and she's going to show some really cool science with Coke and Mentos.
What gives pop its bubbly appeal is the gas trapped inside. That's carbon dioxide. As long as the can stays closed, that gas stays suspended in the liquid. However, if you shake the can and open it, that gas evacuates the can quickly, taking some of the liquid right along with it. There are other ways to cause the gas to escape. Just drop something into a glass of soda and notice how the bubbles immediately form on the surface of that object. Why does it work? Let's take a closer look at Mentos to find out. There are very micro pits covering the surface of the candy. These locations are called nucleation sites, and they're perfect places for carbon dioxide bubbles to form. As soon as the Mentos hit the soda, bubbles form all over the surface of the candy. There are micro pits covering the surface of these mints called nucleation sites, and these are the perfect spots for carbon dioxide bubbles to form. So once they hit the surface of this soda, all of those bubbles will form and be pushed up and out of the bottle, like this. Now that we've seen what one Mento can do, we have 8 bottles of pop here, each equipped with a specialty cap with a smaller opening, which will force more pop through a smaller opening, creating more pressure and an even higher geyser.
Imagination Station is staying flexible and bringing you the same great science experiences you know us for, now in a virtual format. You can sign up for our virtual workshops online at imaginationstationtoledo.org, or you can find and register online at gswo.org. Click on the Activities tab. And when you're ready to pay us a visit again, make sure to book a ticket to our brand new KeyBank Discovery Theater. This 8,200 square foot edition will redefine film engagement with a unique immersive experience. Featuring an expansive 58-foot wide 4K screen and laser projection for superior image quality. You'll experience space, oceans, and so much more on an unimaginable scale.
Visit us at imaginationstationtoledo.org.